In the last two episodes, we explained what AI really is and why it doesn't think like humans. Today, we'll reveal how AI actually learns from data and why that matters. It learns from data. It doesn't learn the way humans do. Every image it recognizes and every sentence it writes comes from examples. Those examples are collectively called data. More diverse data gives AI more examples to learn from. Data can be images, text, audio, sensor readings, or video. Think of AI as a student studying many examples. We show the student examples paired with the correct answers. The student makes guesses, checks mistakes, and adjusts over time. This repeating process is called training. Training tweaks internal settings so future guesses get better. Imagine an animation. Data enters training, forms a model, then produces outputs. A trained model is what we use to make predictions or create content. Give it new data and it returns an output, like a caption or recommendation. Models can be wrong if the training data was limited or biased. That's why diverse, high-quality data and testing are important. In short, data teaches, training builds, and the model performs. Want to learn more? Check our beginner's guide to how AI learns. Humans learn by finding meaning in context. AI learns differently. It looks for patterns in data. AI does not think or experience awareness. Instead, it adjusts internal values to improve predictions. This repeated adjustment process is called training. Watch the training loop. Examples, predictions, feedback, adjustments. First, the model is shown many examples with labels. It makes a prediction for each example, essentially a best guess. Each guess is compared to the correct answer, and error is measured. Small internal values are adjusted to reduce that error. Over time, the loop repeats many times, and predictions gradually improve. Simple takeaway: AI learns by pattern finding, not by thinking. AI systems today can label photos, translate languages, and draft documents with impressive accuracy. That accuracy is real, measurable, and often reliable in controlled settings. But accuracy is not the same as intelligence. Machines can be right without understanding why. In this video, we'll explain how learning from feedback creates patterns, and why pattern mastery can look like understanding. We'll use a simple metaphor. Imagine a student who memorizes every practice test, but never learns the lesson. Captions are enabled for accessibility. Let's begin with how AI learns from feedback and examples. Most modern AI learns by example. It sees inputs and the correct outputs and adjusts internal settings. When the model guess is wrong, training algorithms change its internal patterns to reduce future errors. When it gets answers right, those configurations are strengthened. Over millions of examples, patterns solidify. This process optimizes for accuracy, fewer mistakes on the tasks it has seen during training. But the machine does not form concepts the way humans do. It matches inputs to patterns that predicted success before. So accuracy reflects statistical reliability on learned patterns, not necessarily causal understanding of the world. Imagine a student who practices only by memorizing every past test, question and answer pair unknown tests. The student scores perfectly because the answers were memorized, not because the underlying ideas were grasped. But if the exam changes format, asks for reasoning, or combines concepts differently, performance can collapse. This is exactly what happens with AI. It generalizes from patterns, but can fail when the pattern shifts or deeper reasoning is required. Simple line drawing diagrams on screen will illustrate the student tests, memorized answers, and unexpected questions. These visuals help separate surface accuracy from deeper conceptual understanding. When systems rely on pattern matching, they can be brittle. Small distribution shifts cause large errors. Models may exploit shortcuts in data, use spurious correlations, or hallucinate plausible but false answers. High reported accuracy can hide these weaknesses, especially when tests mirror training examples too closely. Real-world stakes matter in medicine, law, or critical systems. A memorized shortcut can lead to harmful outcomes. So we must evaluate models for robustness, fairness, and true generalization beyond raw accuracy numbers. Understanding failure modes helps teams design tests that reveal when a model is memorizing versus reasoning. There are practical ways to move beyond memorized patterns toward more reliable, interpretable AI. Improve data diversity. Test on out-of-distribution examples and use causal or symbolic methods where appropriate. Combine human oversight, interpretable models, and rigorous evaluation to detect shortcuts and spurious behaviors. Design tests that change question formats, require explanation and probe for underlying reasoning, not just answers when systems fail. Treat mistakes as signals to improve data model design and testing regimes. In short, accuracy is essential, but coupling it with robust evaluation and reasoning-focused design brings us closer to true intelligence. More data doesn't always mean better AI. Quantity matters less than the quality, diversity, and relevance of the data fed into models. People often assume more examples will fix problems, but if training data contains errors or bias, the model will learn and amplify those issues. In this video, we'll define 3 core data problems: bias, incompleteness, and staleness, and demonstrate their effects with clear visualizations and examples. We'll also compare biased and unbiased outputs side by side and end with practical steps to audit and improve your data quality. Expect clear factual examples, steady pacing, and a focus on actionable recommendations for teams building or deploying AI systems. Let's begin by unpacking why sheer volume can be misleading and how data flaws become model flaws when left unchecked. Quantity can improve statistical coverage, but only when the underlying samples are representative and accurate across contexts and populations. If a dataset overrepresents one group or situation, models trained on it will perform unevenly in the real world. Despite huge volume, more data can mean more noise. Poor labels, duplicates, and low-quality records can drown useful signals and reduce model reliability. Quality controls, curation, and balanced sampling are essential. Without them, larger datasets can magnify mistakes rather than correct them. Think of data like ingredients. Quantity helps only when each ingredient is appropriate, fresh, and combined with care. Next, we examine 3 specific data problems and how each one undermines model trust and fairness. In different ways, bias appears when certain groups or viewpoints are underrepresented or misrepresented in training data, creating skewed model behavior. Incompleteness means missing contexts or rare cases. Models trained on incomplete data struggle with edge cases and unusual inputs. Stagnance happens when data no longer reflects current reality. Outdated trends, language, or behaviors make models less accurate over time. Together, these problems cause models to generalize poorly, produce harmful outputs, and give users false confidence in automated decisions. We'll now show a side-by-side example: the biased output versus a corrected, more representative output for the same prompt. Notice differences in tone, accuracy, and fairness. The corrected output reflects balanced examples and clearer, less assumptive language. Biased training data can reinforce stereotypes, affecting hiring tools, recommendation systems, and content filters in harmful ways. Models can make confident mistakes plausible, but incorrect outputs that mislead users because the model's certainty is not grounded in true knowledge. When AI appears intelligent while being wrong, decision makers may over-rely on it, amplifying errors across business processes or public services. Unnoticed data issues eroded trust. Users expect transparency and accountability when AI affects outcomes that matter to people's lives. We provide a concrete example: a recommendation system trained on biased browsing histories that systematically excludes certain groups. That exclusion leads to lost opportunities, reputational harm, and legal risk. Outcomes that more data alone cannot fix. Start with a data audit, map sources, assess representativeness, and flag missing or outdated segments. Before training begins, Measure bias with metrics and targeted tests. Evaluate performance across demographic slices and edge cases, not only aggregate accuracy. Curate and augment deliberately a diverse, validated samples and correct labels, rather than indiscriminately collecting more unvetted data. Monitor models post-deployment. Continual evaluation detects staleness and prevents drift as real-world usage evolves. Adopt transparent practices. Document data sets, version controls, and decision logs so stakeholders can inspect and challenge outcomes. Audit your data quality now. Small disciplined efforts beat larger. Careless collections improve data. Improve AI. Audit your data quality today. Recommendation systems, voice assistants, and image generators learn from past examples and patterns at scale today. They spot regularities to predict what usually comes next. Very fast every day. This makes AI feel smart, because predictions match common cases in many tasks regularly today. But pattern-driven prediction is not the same as reasoning, or understanding, or implicit knowledge. When scenarios change or rare inputs appear and noise increases, predictions can break. That explains why image generators or assistants sometimes confidently produce false or misleading outputs today. AI predicts, it does not reason. So human judgment remains essential. Always use AI to augment checks and bring context. Be curious, verify results, and ask follow-ups. AI learning is powerful, capable of recognizing patterns from huge datasets. But its strength comes from statistical correlations in data, not conscious insight. Models compress vast examples into compact, internal representations that capture recurring structure. Those representations allow the model to predict the most likely next output. Prediction is pattern continuation, based on probabilities, not a comprehension of meaning. Understanding implies beliefs, goals, and subjective experience, which AI does not possess under the hood. Training adjusts millions of parameters to improve prediction accuracy. The model evaluates possible responses and ranks them by learned likelihood scores. It can combine facts it saw during training, but it does not verify truth. Biases and gaps in data lead to confident, yet incorrect predictions. That is why verification, fact-checking, and human judgment remain essential. Probability distributions shift as the model weighs options and selects an outcome. Knowing this distinction helps us set realistic expectations and appropriate uses for high-stakes decisions. Rely on humans or tightly validated systems, not raw predictions. Designers should build feedback loops and transparency into AI deployments. Policymakers should require audits, clear labels, and accountability for automated outputs. It doesn't think, it doesn't understand. Predicts AI explains simply. Documentary series. Now that you know how AI learns from data, the next question is, why does it sometimes get things completely wrong? That story starts in episode 1 and episode 2. You'll find them in the documentary playlist posted in the comments section.